So, question. What are you going to do as a teacher your first day of school? Hand out a bunch of papers, talk about the course? How about doing a lab? That's what I do every year. Day one, lab. They like that. I know they're just coming off of summer vacation. They want to do something, be active still. But they don't have any chemistry under the belt. How could they do a lab? How could it be a lab that actually has some challenge to it? Well, I think you're going to like this one. It's called the Mystery Solutions Lab, and it's done on a micro scale level with little cassette boxes, and the solutions are in these little vials. And they're numbered and lettered, maybe an A, B, C, and the corresponding 1, 2, 3. And they contain 3 solutions. Now, I'll tell you that those solutions, I don't tell this to the students, they don't need to know, it doesn't help them. One of them is an alum solution, that's potassium aluminum sulfate. Another is a solution of vinegar, and another is a baking soda solution. And the other set of solutions, that's ABC, 1, 2, 3, has those exact same 3 solutions, but in a different order. And they are to figure out which letter corresponds with which number. Does A match up with 2, and B with 3, C with 1, or is it some other combination? And they don't all have the same set of letters and numbers. In fact, the set I picked up here is MNO 13, 14, 15. So that way they're not going to copy off the people next to them. They don't know that it's actually the exact same matchups, just shifted over 3 letters and 3 numbers. Another thing I do with this, they're obviously working in pairs. One person has one set of solutions, the other student has the other set of solutions. They're not allowed to mix a lettered solution with a numbered solution. They can only work with what they've got. I don't even tell them about mixing them. I just tell them, how do you solve this? And they brainstorm that for a while. Of course, tasting it comes into mind. They bring that up. And we rule that out. Smelling, that could actually work. In fact, if you use vinegar, you could tell one. And for that reason, you may want to swap out the vinegar for a citric acid solution. Has the exact same reactions, doesn't give away with the smell. Has no smell to the citric acid solution. But invariably, some student comes up with the idea of, hey, maybe if we mix them with each other, something will happen that'll help us figure out which one's which. So that's what we do. But I don't have the students sitting side by side on this first day with their partner. Instead, they are either back to back or back to back and across the room from each other. It depends on how serious you want to get with this. And they can communicate not by any kind of word of mouth. They can't look at what the other person's doing. They can simply pass notes, which students are usually very good at doing. We say faxing messages back and forth, or if I had it set up with a class bunch of laptops, they could actually email each other back and forth, or text message. Maybe that's what I'll do. Assuming they're all going to have cell phones, and I'll have them text messages. They'll get done with the lab in half the time, right? OMG, A is 2. No, okay. But how do they go about doing this? And I'll talk about the construction of this in a second. But the nice thing about these cassette boxes, and it's almost to the point where the students have no idea what this is. What's a cassette box? Okay. Opens up like that and gives you a nice little rack there that you can have at your desktop. And the solutions are here, 13. I have it not only numbered on the pipette, but also on the cassette box, so they know it goes back in there. And if I want to see what happens when we mix 13 with 14, we simply take a drop of 13, put it down there, shows up. Oh, this is a little piece of acetate sheet cut out of from an overhead projector. It's almost to the point we don't know what an overhead projector is. All these artifacts from teaching past. And now solution 14 we're going to put right on top of it and see what happens. And doesn't seem to be anything going on between 13 and 14. Let's try 14 and 15. Try 14. And 15. Oh, now I don't know if that's showing up well, but sorry, we need to record these, don't we? 13 and 14, we're going to have, now this is the students. I haven't told them what to do. How do they say that 13 and 14 do something or don't something? They often do put a plus or an and sign, and they usually use an arrow, even though they haven't been told anything about equations, or they put equals. So 13 plus 14, if you want to do that way, equals or makes or produces nothing. They'll usually put clear. Of course, it started off clear, so that's nothing or no reaction. But 14 and 15, they would say milky or cloudy. And what's the other combination we have to do? 13 and 15. So we'll do that, 13 and 15. And we can see little bubbles quickly form in there. They race to the top. So 13 and 15 bubbles. Meanwhile, their partner is busy at the other desk, not looking at what that person did, just relying on what they've written about it. It forces them to write about these things. Has their own separate acetate sheet. Quick word about that. You see that little blue dot I put on the acetate sheet? Any idea why that's there? 2 reasons. When it falls on the floor, it's easy to see. And when the students turn these cassettes back into me at the end of the period, at a glance I can see, because it fits right in there, I can see the little blue dot that is in there, okay? So, now we're going to do M and N. Here's solution M and N. And, okay, that turned cloudier off the bat. There's a big old bubble in the way there, but that's just happened from when I dropped M in there. Let's try N and O. Oh, bubbles for sure, fizzy. And finally, M and O. They should be predicting, well, actually they wouldn't know because they haven't seen their partner's facts yet, that M and O should do what? No reaction. Okay? The cleanup of these, by the way, is literally this fast. That's in there. That's back in there. So the lab is very quick in that regard, but now comes the real challenge. What's what? So solving this puzzle, this is not trivial. We have that 13 and 14 did nothing, and we had that M and O did nothing. So 13 and 14 corresponds to M and O, but which is which? Maybe 13 is M and 14 is O, or maybe the other way around. We don't quite know that yet. So students often, there are several ways of solving this. And again, their first day, they're just up for the challenge. But look at this, for instance. The only solution that was involved in both cloudy and the bubbles would be 15. And over here, the only solution that was involved in both cloudy and bubbles was N. Now again, they're getting this together, but by writing back and forth. So N must equal 15. The only thing that was involved in both the nothing and the cloudy was 14. And over here, nothing and cloudy was M. So M must be 14. Obviously, by process of elimination, 13 must correspond to O. And that is the correct matchups. So, what I like this lab. It's a first day activity. There's not chemistry involved in it. Well, there's a lot of chemistry, but we're not learning the chemistry. But we are learning the reasoning skills and the problem solving skills. And they get to see some reactions on the very first day. Why do I have this whole back-to-back thing? What's with that? Why not just have them do it sitting in a lab station? Well, this is another important lesson. I want them to realize that chemistry is not a spectator sport. So often when you pair them up like that, one student kind of takes control of the whole thing. If I had them side by side, the more confident student, not necessarily the more competent, but the more confident student would probably grab both of me doing it all, and the other one just kind of sitting there watching and hoping that the partner gets it right. But that's not what chemistry is about at all. They have to have competence and competence, and the way they get that is by participating. So this forces both students to do the lab, think it through, communicate with each other in writing, not verbally, but in writing, and be accountable, essentially, for what they've observed. And I think that's a large part of what chemistry labs are all about. Thank you.